All right. Thank you all for coming to my talk. We're going to be, my name is Rahat. First of all, I'm a developer advocate over at Polygon. You can follow me in different places at Rahat Codes. This is the only slide that's going to be on this presentation. We're mainly going to be coding, looking at some code, and just having fun playing around with stuff. But today we're going to be looking at how you can add some play-to-earn mechanics to a browser game. And the game that we're going to be adding play to earn mechanics to is this rock, paper, scissors game, which I tried to pick a game that I felt was very universal among folks. So I think a lot of people are familiar with the mechanics of this game, hopefully. For anyone who's watching now, if you want to real quick drop in the chat, would you like me to pick rock, paper, or scissors as I try to defeat JavaScript on the actual game? Someone asked, what is my Twitter? I will drop it here. But yeah, so Alex, since you're participating, rock, paper, or scissors? Rock. All right. So rock, nobody wins. Unfortunately, JavaScript chose the same exact thing. All right. So Moses said paper. Let's try paper. Again, nobody wins. All right. So our luck is not great right now, but hopefully it'll change once we add some play to earn mechanics to this game. So if we were to take this game right now, it's just a simple browser game, and I'll run through the code real quick. It's very ugly written. It's just a gigantic switch case. Just checking if there's rock, paper, or scissors being chosen, and then setting a winner. This is definitely not optimized code. Please don't copy and paste this and put it into production. But it does the job, right? It does what you need it to do. And when you're in a hackathon trying to put together stuff, that's all you need sometimes. But it does the thing. It plays rock, paper, scissors. Let me try scissors. Wow, nobody's winning ever. Hey, the opponent won. But so far we have never won. That's fine. And so there's not a lot going on, right? There's just this little game engine function that handles everything. But how do we add some Web3 mechanics to this game? I've got this new component here. Uses the same sort of game engine, but I call this the Web 2.5 game. Call it Web 2.5 because all we're kind of doing here is just adding this handle wallet connect function over here. And what we're doing is I imported the ethers library in here. And what I'm doing is just some sort of handle wallet connect where I pull the Ethereum object out of the window. The Ethereum object is available in the window. And as long as you have a browser injected wallet, like a MetaMask in there. So this is just a quick couple lines of code on how to connect to the wallet and essentially just, paste that onto the page. We're going to instantiate a provider that's given to us from Ethers. Once we pull the Ethereum window and give it that object, what we can do is use this function where we do this provider.send and it sends this ETH request accounts string, which actually requests the accounts. So let's see what that looks like. I'm going to comment out this Web2 game. And we're going to graduate to Web 2.5 by adding a wallet connect. So now we've got this connect wallet button. Hit wallet connect. Hit next, connect. Wonderful. Now I've got my, address displaying. If you wanted to do something even cooler, you could resolve if there's an actual ENS username or anything attached to it. But let's give it another shot. Let's see in Web 2.5, are we any better? Rock, paper, scissors. Somebody pull something in there. Come on, rock, paper, or scissors. All right, so the last thing I think Moses said was paper, so let's try paper. Hey, Web 2.5 helped us win something. All right, so that's Web 2.5. We added a wallet connect feature. If you want to do some gradual steps of taking an existing game or an existing application into the Web3 world, this is a good start, right? We've got our Web 2 connect not Web 2, Web 2.5 game with a connect wallet function in there. But I want this to be a Web 3 game, right? So how can we move this onto blockchain? I'm now going to live code a smart contract for you that will handle wagering some functions and trying to essentially, oops, trying to essentially, you know, we're going to have a smart contract that can have some money loaded into it, let people play rock, paper, scissors. And if they win, they receive all the money that's in there. So I've just done some like pre-work of like adding a license identifier and the Pragma Solidity version of this contract. This is going to be a very, very basic contract. We're not going to do anything really robust. Nothing is tested. And there are some improvements that can be made on this game that I will task all of you with doing because we're specifically on, you know, this Chainlink hackathon. You can use Chainlink to make my code here a lot better. But let's start with like a very basic implementation of this. We're going to call this contract game because I don't know how to name things. We're going to have a unsigned integer called balance, and that's just going to like essentially tell us, you know, what the balance is. I'm going to write a constructor here. I don't think I'm going to put anything in here for now. Maybe we'll put something in later, but we'll just leave that there. I'm going to create a function called receive money. Receive money is just going to allow us to load some money onto this contract so that when somebody is playing the game, they can actually, somebody asked me to zoom in, so I'm zooming in. All right. Hopefully that's a little bit better. So a receive money function to load money onto the contract. So with that, I'm going to make this public so that anybody can use it. And I'm going to use this payable keyword. Solidity has payments baked in to it, like at its core. So if you want to be able to send money, receive money, this is what's going to allow you to do that. In this case, for this function of receive money, we're just going to look at the balance and we're just going to update it with the message.value. What does this mean? This means that we should spell things correctly. But whenever someone interacts with this, you know, function through the smart contract, they can load up this contract with whatever amount of money they decide through this message.value. So message.value will just give you the amount of money that is being transacted on with this specific function. And we'll see that in action in just a little bit. Next up, yep, so someone said Chainlink for randomness. Yes, that is how you would improve my smart contract. But we'll get to that in a bit. So function receive money is done. Now let's do like a function for get balance. Might be a little redundant, but just to see, you know, how that would work, we'll make this a public function that is viewable and just returns an unsigned integer. And that is just going to return the balance of this specific contracts. And that would just return to you that balance. Next up, let's do the play functionality. Now, I'm going to still allow JavaScript to decide the winner because regularly in Solidity, you can't really do true randomness. You can do like some pseudo randomness stuff, but y'all are participating in the Chainlink, you know, hackathon, and Chainlink has an amazing and awesome, cool tool for actually doing verifiable random numbers. So definitely look into that if you would like to improve on this a little bit further. But for the sake of this workshop and for the sake of time, I'm just going to allow JavaScript to do so. And how are we going to do that? We're going to just create a function called play. It's going to take a Boolean called 1. So that's going to come from JavaScript. Once again, this is a payable function. We're going to send some money to people. It is public, and it's going to return a string, which we'll just keep in memory. Now, simple kind of like if statement, if 1 equals true, what we're going to do is take the address payable to. So this is an address that we're going to be paying to, and that's going to be the message.sender. So if they win, we're going to send them some money. And what amount of money are we going to send them? We're just going to send them whatever's in the balance right now. So that get balance function that we wrote earlier that returns the balance is here. Cool. Now, otherwise, we take their money, right? Else receive money. We're going to have them wager some amount of cash, probably like 1 Matic or something, and take some money. And then we're going to return a winner. Actually, I don't think we need to return anything here. This, yeah, doesn't matter if we actually return a winner or whatever. We'll just have it like do this functionality. Cool. So again, nothing very complex, nothing too big. We're just saying if there is a winner, we send them money. If there is not, we take their money. And this is like a very, very basic implementation of adding some bit of play to earn mechanics to your game. This is just like sort of a gambling rock paper scissors style game, but this is really meant to just give you an idea of how you can add those like little functionalities of like receiving, sending money. So we've got this going on now. Let me go ahead and compile this contract. Compile game.sol. What happened? Ooh, I missed something somewhere. Let's see. I had a version of this earlier that worked. Rather than us debugging whatever like little tiny thing I missed. There we go. Pretty much the same thing, except I think whatever little function that I did not do works. Perfect. Cool. So that is done. I'm going to copy this ABI code here. So ABI code is basically what Solidity compiles down to. Solidity is high level language, and when you're putting stuff like onto the blockchain, the ABI code is actually what gets deployed onto the blockchain. ABI code is also what you need on your front end for JavaScript to be able to like traverse the smart contract and actually be able to essentially connect and know like what functions need certain inputs or whatever. So I'm going to head back over to my React application, and I have the ABI code inside this ABI.json. I'm just going to replace it with my new one. So like I said before, this gives us like, all of the inputs, the functionality that's available on this contract. You can sort of look at it as like a map for how we need to traverse this smart contract. So we've got that. Cool. Let's actually deploy this thing. I'm going to do injected web3, which is just connecting to my MetaMask. I'm connected to this account. I am on the Polygon testnet for Mumbai, so that's where this is going to go. Let's hit deploy. Let's see, it's going to cost a little bit of Matic to actually get that deployed. Creation of game is pending. Should take not too much longer. Let's take a look at some questions that you all have. I like how you have Web 2 and Web 2.5. Thank you. Is that secure? Probably not. This is, again, just a very basic implementation. So I would definitely, look at, how to make this a bit more secure. We're looking at this from just a hackathon perspective of getting something working real quick. Oh, somebody told me the S on returns. That's what was that is what I was missing before. It's always like some like thing going on with spelling. Let's see. Very clever to build a boilerplate tutorial we can easily improve. Yes, that's kind of like what I wanted to give y'all. And yes, looks like we have successfully created our contract deployment. Let's view this on the block explorer. This is Polygon scan. If you've ever used Etherscan, this is pretty much the exact same thing, just on the Polygon, blockchain. Again, this is on the Mumbai network, so this is all done with test Matic, so you don't have to use any actual real money to do this. But cool, we've got our contract here. I'm just going to copy this contract address real quick to make sure that we are connected to the correct one. This is an earlier contract I had, but let's test this out first in Remix, right? Make sure things are working the way we expected. So if we get to do this get balance thing, it was unnecessary, but the balance returns to a 0, which is what we expect. Let's actually load some money onto this. We'll do, let's see, Polygon scan, unit converter. I'll put, I don't know, let's put like 20 Matic on this. And I'm going to copy this value of way just to make sure that I'm doing this properly. The cool thing is, like, when you're building on, Solidity versus Polygon, all the units and stuff are all the same. So like the smallest denomination of a Matic is also a way, just like the smallest denomination of like, Ethereum is way, which is just like 1 with 18 zeros. So this is going to be what 20 Matic is equal to. So I need to make sure I put that here in the value. That worked out the way I wanted it to. Yes, it did. Cool. And since that's in the value now, let's hit receive money. Awesome. This is going to cost me 20 Matic. So I'm going to load this game up now, this contract up at 20 Matic, so that people can start playing. So hit confirm. Receive money errored. Whoa. What happened there? Let's just try to do something smaller. See what happens. Let's just put 5 Matic in here. The unfortunate side effect of doing live coding, it doesn't always work the way you thought it would when you were practicing it. Receive money. Wonderful. 5 Matic. Confirm. Oof. Okay. So let's use an earlier version of this, just so, again, for the sake of time, while formatting outputs, so there's something wrong with my formatting somewhere. So let's do this. I'm going to undo this and do the earlier version of this contract address. I'm going to copy this contract, look that up on Polygon scan, make sure that's still a thing. Cool. I did test this out like 30 minutes ago with 1 Matic. So currently the balance is 0 Matic. So we're not going to win anything, but let's try to lose real quick. Let's try to lose. And what we're going to do is, so now I've got my Web3 game, right? So just real quick, going through how we connect to the contract address. We just import the contract address. Again, I'm using Ethers. I have this transact game function here. And what we're going to do is, again, pull the provider out of Ethereum, and we're going to connect to the contract using the contract address, the ABI, which I'm importing, as well as getting the signer, which is just the address of the person. And I'm going to use this play transaction, which is that play function that I just wrote earlier. And I'm going to pass it a Boolean, which I'm going to pass to the transact game up here. And we're going to make the value, I believe this is 1 matic, or whatever 1 to the 18th power of way is. And we're just going to await the play transaction, make sure that actually goes through and happens. Cool. Otherwise, the game is exactly the same. Let me just make sure that I actually update this. If y'all could just drop in the chat, do you want me to do rock, paper, or scissors? Well, I get this all set up. Web3 game, no, cancel, is all set up. But yeah, rock, paper, or scissors. Just remember there's actual testmatic now being wagered. So you will either cost me some fake money or win me some fake money. Well, right now there's nothing on the actual contract, but we can go ahead and try it out. No takers yet. We'll do rock for now. Oh, I won. Nice. I won. Nice. But there's nothing on there, so nothing happens. Let's do paper. Why am I still winning? All right. Paper again. Nobody wins. Cool. Nobody wins. Confirm. And I believe that will add some matic to this contract. Oof. Okay. What are we doing here? Let's use this contract actually, just to. The consequences of live coding. Sometimes I wish I just recorded something and just showed you the recording of what I did when it worked, Let's see, view on Block Explorer. This definitely already finished, as we saw before. Contract deployment, view on Block Explorer. Okay, here's the contract again. I used the ABI from this. That's probably what is the issue. Update that. This is the new ABI, the new contract. Let's do rock again. Opponent wins. Wonderful. Confirm. Ooh, we're still getting that same error. Something with the RPC. I wonder if that's just an endpoint I can switch out or something. Let's look at that again. It seems to only happen when I'm trying to add money. So it looks like the issue is with the add money function. So let's see, receive money. There's something wrong here because the other stuff seems to work. Let me just try true. Some live debugging. Transact to game.play pending. Pending. Come on. Let's go. Blockchain. Let's go. It's going to work soon. So we had a question. Inside play, wouldn't it be better to use a ternary operator, something like one, transfer money, receive money? Wouldn't it be more gas efficient? That is correct. That would be much more gas efficient. probably something you can do and take this to improve it. Okay, so this transaction is still pending. Let's speed it up. Hi, save. Oh, it was a success, apparently. Okay. Okay, so transactions are going through. I have a Matic in here. That's wonderful. Great. So let's try it out over here now. Let's do rock, opponent wins. What should happen when I confirm? It seems like all is good now. Might have just been some weird thing going on with RPCs. It looks like it's all good. Let's view this on Blockcore. So this was from my front end. As we can see, it was successful. Let's go back to the contract. Yes, 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 yes. Everything is finally populating. So looks like it's working. Let's actually try to win. The opponent won. So right now I've got what? 486 Testmatic in here. Let's try paper. Nobody won. Damn. All right. Confirm, whatever. Let's do scissor. Yes. I finally won. So when I allow this transaction to go through, what should happen now is that I receive all of the Matic that is in this pool. So let's hit confirm. Let's take a look at that transaction here. Do I want to speed it up? Let's just look at the view. Okay, it was successful. And I know that was still pending. According to MetaMask, it's still pending, but as you can see, it was successful. Probably just going to take MetaMask a second to actually, populate that. But what should happen from this contract is now the balance that was in here would be sent back over to the winner once this actually finishes up. Let's set that to high so we can see that happen. Okay. Cool. I set it to high. It's still pending, but it is calling the send function now, which is wonderful. And eventually, when that actually goes through, I should receive the money that was in the pool, which I think was just like one Matic. So that's all good. And yeah, this is kind of like how you would add some basic play to earn mechanics. Some of the things that I would definitely mention for improvements for this game. On the front end side, we're only looking at doing things for people with like browser injected wallets like MetaMask. So we definitely want to be more inclusive of people who have things like mobile wallets, for people who use hardware wallets or anything like that. So I definitely recommend implementing something like Wallet Connect to make sure that on the front end you're taking care of being more inclusive and getting more folks into your games. Number two, which we kind of like mentioned before, rather than letting JavaScript actually, transact and do all of the stuff for this game and actually decide the winner, you can use Chainlink's verifiable random number generator to actually handle the game logic itself. And that's something you can take and build on top of something like this. And that's really cool for like not just like a very basic rock paper scissors game like this, but like if you're doing things like adding stats to a character, or if it's like an RPG game where people are attacking each other, doing some calculations for randomness of critical hits or something like that. This is you know for this implementation, you would just do like maybe I need like a 1, 2, or 3, and then based on that number, I pick rock, paper, or scissors. But going beyond that, going beyond just like a basic browser game like this, doing things where like you use that randomness for stats, for interactions between players, interactions between different people, like that are all cool things to build upon this basic sort of implementation here. But otherwise, I'd love to open this up to questions, anything about the code or in general. Would love to open it up to you guys. Thank you, Chainlink folks, for dropping that Chainlink documentation there. Cool. I'll give folks maybe another minute or so if you need to ask any remaining questions. Cool. Hopefully, that all kind of made sense. Live coding always has its perils, but we were able to kind of make it through. So thank you all for tuning in. Appreciate you.